Hey, so just a short little add-on video here from our previous video of the introduction to hydrocarbons. I just want to talk about sort of naming straight chain alkanes. So alkanes here, and we first talked about this sort of the fact that they had the different elements of hydrogen here. You know, we have a hydrogen atom and we have our carbon atom. But today we're just going to be sort of looking at how we can sort of name and identify each of these molecules. So this here, the way I've drawn this with the sticks and the elements displayed is called the displayed formula. And obviously from the last video we know that this is called methane and has the formula CH4. You can count this up, 1, 2, 3, 4, boom, right there. Now, a alkane is what's known as a saturated hydrocarbon. So essentially what that means is there's only single bonds here. There's only single covalent bonds here. Yeah, single covalent bond. Now, if I were to draw a alkane with 2 carbons, we can see that we have got an additional 2 hydrogens here now. So obviously we have our new formula, C2H6, and this is called ethane. So what I'm going to do is I'm just going to label up the first 4 successive alkanes of their homologous series. So here we have 1, 2, 3, which is propane. Now, propane has the formula C3H8. And we can see that it has 3 carbons, 1, 2, 3, and it's got 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. And the final hydrocarbon I'm going to look at here is butane. You may have heard of this molecule out of context, all the previous ones out of context from what we're looking at today, but this is the displayed formula for butane. C4H8. So you can count them up, C4H10. And obviously you can count up the 4 hydrogens here, the 4 hydrogens here, and then the 2 here, and then your 1, 2, 3, 4 carbons. But what we really want to be looking at today is how can we name some alkanes with a higher number of carbons. So we have 6 carbons here. 3, 4, 5, 6. 1, 2, 3. And really, what we're looking for is, we'll put these in a different color because they can stand out more, so you can see the difference between the carbons and hydrogens. So what we're looking for here is how could we name an alkane with 6 carbons? Well, what else relates to something with 6 points? Well, if you're thinking of the shape called this shape, six-sided shape, well, our prefix is going to be hex. And this is relatable for pretty much all of them up to probably about 12. So say we've got 7 here, which is actually called heptane. Mistake corrected from my previous video, but well, septane and heptane can be used interchangeably. However, it's more typical to use heptane. So 1, 2, 3, 4, 5, 6, 7. And I'm not going to draw the hydrogens here, but you should know that they are on the ends of every single one of these covalent bonds coming off. So we know this is called septane. Now, if I were to draw a alkane with nine carbons, I'll just give you the formula here, C9H, and this will be 20, following our general formula of CnH2n plus 2. Just give you 5 seconds to possibly try and name this alkane, dependent on what I've taught you before with the shapes. So if you identify this alkane as nonane, you would be absolutely correct. So obviously we know we've got our suffix here, ane, for the alkane homologous series. That's sort of how we define the homologous series of organic compounds and molecules. We use the suffix for ane, and then we have our non, which tells us how many carbons are in this alkane, which are 9 carbons. So we're gonna do one more here. We're gonna go for an alkane with 12 carbons. So we know this will have a number of 26 hydrogens. So I'm going to give you 2 seconds here, just to see if you can sort of draw this. I'm going to give you a clue, an alkane with 10 carbons and 22 hydrogens, so an alkane with, yeah, is going to be called decane. So I'll give you just a second here to think if you can name this. So this molecule here would actually be called dodecane. Just as you would name some sort of 12-sided shape with a dodecahedron example. You know, you have your 12 carbons, and this is what indicates for the suffix dodec, and then you have your ane, which is for the alkane homologous group. So here is just a nice short video of naming alkanes, and hopefully you are now confident that you can name some longer chained alkanes.